Hello, Namaskar, Vanakkam. Welcome to chapter number 4 of Science Curiosity textbook for students of class 7, The World of Metals and Non-Metals. We've already explained this particular chapter in Hindi. So those of you जिनको कि हिंदी में पढ़ने ज़्यादा अच्छा लगता है, उस वीडियो को देखें जो कि हिंदी की प्लेलिस्ट में है. This particular video, the explanation will be done in English and subsequently we will also do the question and answers which are there at the end of your textbook. So, before we start the statutory information, please share all the CBSE with Sudhir videos. Class 6 videos, if you have seen, please share them with your juniors. Class 7 videos, share it with your classmates and batchmates. Next year, share both class 6 and class 7 videos with your juniors and super juniors. Okay. Also, subscribe to the channel if you have not done so already and press on that bell icon so that you can get the notification for the next video that I post, and I post quite regularly. Okay, hashtag Science with Sudhir sir. Now, let's get into the NCERT textbook. And as usual, it starts with a fascinating story about Yashwant and Anandi who live in a village in Rajasthan. Okay, Rajasthan, which is in the northwestern part of India, the desert state of Rajasthan that shares its border with Pakistan. Now, their school has assigned them a project to learn about craftspersons who work with metals, different kinds of metals, right? Now, what they decide to do is that they are not going to ChatGPT or Google and taking down somewhere. No, they are hardworking students. So they decide to go to the local iron smith, that is people who work with iron, okay, loha, right? And learn firsthand from what they observe. So they interact with this elderly craftsperson whose name is Sudarshan uncle. So Yashwant asks him, which items do you generally make? So they talk about, we make tawas, baltis, that is the iron bucket. I don't know if you have seen them. Tongs, which are used in the kitchen, also in different kind of implements for iron smiths. Farming tools like spade, which are used in the fields for agriculture by the farmers. Axes, trowels, and rakes. Okay. Anandi asks, what material are they made of? So you are seeing out here. Now, this is some kind of a fork with which you take it out. You hold something with that. This is a hammer. This is made of wood, and this is made of iron, right? This is the favda with which you use in the field, etc., right? So Sudarshan says we use iron metal to make these items. So we also use wood to prepare handles whenever required. So you may ask, why do they use wood for the handles? I will answer that in this chapter. Additionally, we use coal in our furnaces to heat the iron. Now, that's quite a bit of interesting information. Now, Sudarshan, what he's doing is to heat an iron block, and then it becomes red hot. He beats it. And when he beats it, he's able to shape it into an axe. So a piece of iron, which you normally think is very hard, can actually be changed into any shape. So what actually, these days people say you should not cook in, many of the utensils which are like, the stick free, where the dosa or the chapati or any other kind of batter will not stick because it is harmful to you in the long run. So what we did at home was to buy this one. Okay, we bought a whole lot of iron things from this company. It has not been a great experience, I must say. Where you see the tawa, the kadai, these are all made of iron. The frying pan, the grill pan, all these things we bought. The problem is that it's very heavy. Of course, they said that we cannot take it back because we had said that it will be so heavy. We didn't imagine it will be so heavy that it's becoming very difficult to use. So I have just carried. Appa, this is so heavy. I don't know whether you get. We have not even opened it. It is so heavy. We were thinking we will return it, but they have refused to take it. So we'll have to start using it. Now, this is made of iron, and it is very heavy. Okay, there's no way for me to indicate how heavy it is, but I'm holding it with both hands so you can imagine how heavy it is. Okay. It is so heavy, but it is apparently good for your health if you cook your food in iron utensils instead of the non-stick frying pan and stuff like that. Ask your parents, they would know more about this. Now, the first one is about malleability. Okay, but before that, I want to tell you about how can iron, when put in furnace and brought out red hot, be beaten into any shape. That's what Sudarshan uncle has told Yashwant and Anandi. And this is what I want to tell you, because see, my whole idea is that, I will do the syllabus. Syllabus to koi bhi kar dega. My whole idea is also to inspire and motivate you to keep asking the why and how questions. Because when you train your mind to think like that, it will help you when you go in for science Olympiad examinations. It will help you when you go in for science quiz competitions, which I strongly advise you to participate in. If you are a CBSE with Sudhir student, you should take part in science quiz competitions. Go to science Olympiads for sure. I've already told you the book that you should buy, because that will be very useful. The Oswald Books Olympiads. They have an entire series, very helpful to prepare you for the Olympiads. You can use my discount coupon code Sudhir10 so that you can also save some money for your parents. Now, beyond that, the iron can be beaten into any shape when it is red hot because of a property which is called malleability, which is called malleability. Because when iron is put in the furnace, it gets heated to a very high temperature, sometimes around 1000 degrees Celsius. And at this red hot stage, it becomes soft. It's no longer hard like this. It's actually soft. And then it can be bent, flattened, and converted into any shape that you want without it breaking. And what ironsmiths and blacksmiths do is to use hammers or tools to shape it into any kind of shape. You want to make a hammer, it can be built into that shape. You want to make it like this. Now, this would have been made when it is red hot and made into this kind of a shape. And once it is cool, the iron becomes hard again, but it does not go back to its original shape. It retains the shape of whatever you have given, an implement or an utensil like this. Okay, I found this very interesting. So what it means now, malleability is the property by which materials can be beaten into thin sheets. That is the definition of malleability, and that is something which you need to remember. So please remember these definitions. And metals, generally, by and large, most of the metals are malleable. Now, this reason that I have given is not part of your syllabus in class 7. However, I want to tell you, because as I said, if you are going to take part in quiz competitions, you need to have information more than your other classmates, batchmates, or other schoolmates. The metal atoms, about which we will study in class 8 and 9, or they are called ions, they slide over each other. So when they slide over each other, they are able to take any shape that you want to give it. So when a force is applied, the metal atoms which are inside, atom is the basic unit of anything. Anything in this world is made of atoms, right? So atoms slide over each other, and therefore they are able to change shape. So that's what you learn. So with the hammer, if you hit an iron nail, keel, with that, it will change shape. But that's not what we are talking about out here. What we are saying is that the metals, there are many metals which are either lustrous. Somebody asked me after the Hindi video about lustrous. Lustrous essentially means anything which has some kind of shine. Okay, which has some kind of shine. And they are also hard. Okay, I just showed you the weight of this iron utensil, right? So luster shown by metals is known as metallic luster, and materials like copper, aluminum, and iron are known as metals, whereas coal is not a metal, sulfur is not a metal, wood. Does this wood piece have a shine? It does not have a shine, right? Why? Because it is not a metal. So they are all non-lustrous, and they are not as hard as metals. Yes, this wood piece is hard, but is its hardness comparable to the hardness of this iron utensil that I showed you? No, this is much more hard. Whereas this one, if I hit it with a lot of force, it can break. This will not break. Only when I heat it to 1000 degrees Celsius, then I can change its shape. So that is the kind of difference in the quality of the material. So are all metals hard and solid? That's the next question you will ask. Not really. That's what I said. Not all metals are hard and solid. There are some metals like sodium and potassium, which are very soft, that they can actually be cut with a knife. You can use a knife and you can cut both sodium and potassium. There is one metal about which we studied in class 6, which is used in thermometers. Yes, that's right. Mercury, which is actually not solid. It is found in a liquid state at room temperature, right? Which we use in thermometers. Any doubt? Go and see my video of class 6 on temperature. Now, copper, piece of iron, a piece of aluminium, they all become flat when they are beaten. Whereas so the property by which materials can be beaten into thin sheets, that is called, as I said, malleability. Most metals, as I said, possess this property, and that's why you have, like on barfi, you have on kaju katli, you have that thin silver foil. Where did that come from? Right? That is because of the property of malleability of silver, because of which you can make it into a very thin sheet and you can place it over the sweet. Right? You use aluminium foil. You're going on a train. Your mother wants to pack some chapatis. So the easiest thing is to pack it in an aluminium foil, which is silver in color. Now, again, how is that aluminium foil made? It is made by beating that silver into a very thin sheet, which is this kind of a foil. So that is because of the property of malleability. So what in your exam you can get questions is that, they may give you an example and say which property of the metal is being depicted as a result of this, right? So that's why I'm giving you the example so that you are able to remember. A piece of coal or sulfur does not display this behavior, because coal, if you break, it will just crumble and break it into small pieces. Koila, right? Similarly, I talked about this wood. So basically, wood is not completely brittle unless it's very bad quality wood. So coal or sulfur will be known as brittle, which means it can be broken, whereas wood neither gets flattened into a sheet nor breaks into pieces. A good quality wood, so therefore it is neither malleable nor brittle. Wood, generally, if you get a good teak wood, rosewood, that will not be brittle. Okay, it's not like, thoda sa maro, it will break down. No, it will not happen. However, if it's a very poor quality wood, it may happen, but coal or sulfur is known as brittle. Now, we read about in the Harappan society that they knew how to make copper and gold. They use these metals to make jewelry, utensils, etc. However, you don't find Harappans having used iron. Okay, Harappans did not use these kind of utensils. They used largely copper and gold. So it took a long time before iron was actually used in day-to-day activities, because once the use of iron gained prominence in the times that followed, people started using iron much more because they realized that it's a very hardy kind of a metal which can be used. The second property of metals that we come to is called ductility. What exactly is ductility? Let me show you with the help of my notes. Now, you would have, I don't know if any one of you has played the violin or the guitar, right? You have those strings right here. You can see it in the photograph that I have put, and in the close-up that I have put of the strings. They are tied up at different places, and you need to tune it properly so that it gives you the right kind of, you can produce the right kind of music, right? So the property of materials by which they can be drawn into wires is called, I didn't get the chai ki chalni, by which you put the chai and the thing gets stopped there and the tea falls and you can drink it, right? So that is also made by metal wire. That is also because of the property called ductility, where it can be drawn into wires, right? So it can be drawn into wires, and that property is called ductility, and this is possessed only by metal. So these wires that you see in a guitar or a sitar or a veena or a violin, that is all because of the property of ductility. Okay, so that is something. So even here, what you see, the ceiling in Mumbai or the Durgam Cheruvu Bridge in Hyderabad, you see is all made of these kind of metals, and it is because of the property of ductility where you can actually make this kind of long tubes, long wires with which it can hang, and it is also mixed with carbon so that it can carry the weight of so many vehicles and people. So that's called ductility. So here you also see the tea strainer, right? And gold is so ductile. This is very interesting, which can even be asked as a question, that gold is so ductile that 1 gram of gold, 1 gram of gold, which costs some 10,000 rupees now, can be drawn into a 2-kilometer long wire. Okay, that's how ductile gold is. So you see what I've shown you just now. So this suspension bridge, ropes made of steel and non-metal, which is carbon, can carry super loads, and that's why they are used in different suspension bridges. The third quality of metals that I want to talk about is called sonority. Now, sonority is what? If you, I should have got it. I should have got a glass and a tumbler. So just imagine a steel glass and a spoon. Tang, 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 karo, it will make a noise. Or sometimes when a plate falls or a utensil falls in the kitchen, your mother will ask, what did you break? Kind of thing. I remember when I was a child, in our neighborhood, somebody had got married. His name was Papu, and newly married wife. And so the mother-in-law will sit on the balcony, and she will keep ordering the newlywed daughter-in-law. And the daughter-in-law sometimes will drop something in the kitchen, and then she'll say, "Are beta kya toda?" kind of a thing. So because it would create so much of a sound. That lady should have known it is because of the metal's quality called sonority, right? Similarly, if you have seen a dancer, let me show you the help of this thing. So if you have seen a dancer, she would be wearing these kind of gungrus, and the gungrus have thing which kind of rattle against each other. So that's why kind of sound will come, especially when they dance. Similarly, the school bell, tang, dang, 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 dang. Aajkal it has become an electric bell, but earlier or in some village schools, you will find tang, dang, 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 dang. Or when you go to a temple, you ghanti bajate hai na, tang, tang, tang. Okay, 3 times. That is also because of the quality of sonority. So what is the quality of sonority? The quality of sonority is that it enables them to produce a ringing sound, and metals are said to be sonorous in nature. So that's why he's saying the ringing sound of my gungrus and the sound of the school bell. Okay, now next we move to conduction of heat. Now the first thing that Sudarshan uncle told Yashwant and Anandi was that we also use wood. And you must be wondering, why do they use wood? He uses wood because this particular metal, or all metals for that matter, are conductors of heat. They conduct heat, which means heat will be transmitted. So subsequently, when it is put on the fire in order to cook some food, and then if the handle is also made of iron, like in this case, the handle is made of some kind of PVC material, which will not be hot. Okay. Whereas if the handle also was made of iron, the moment you touch it, because it is a conductor of heat, about which we have already studied conductor of electricity in the previous chapter, conductor of heat means heat will be transmitted. So you cannot hold it, right? Because it will be so hot, right? So therefore, you need to make the handles of some material which will not conduct heat. For example, any kind of PVC, plastic, or wood. Which is why if you see in this particular activity, if you have this spoon which is made of metal, the handle, right, this will be hot if this water is hot. Whereas this one, since it is made of wood, will not be hot because it is not a conductor of heat. So all metals, most of them are conductors of heat. So the transfer of heat from one point to another of a material is called conduction, and materials that transfer heat are called conductors. So metals are good conductors of heat, whereas wood is a poor conductor of heat, right? So metal vessels, that's why yahan par, and this can be asked as a why question to you in the examination. Now we understand why metal vessels are used for cooking, but their handles are made with wood or other materials that do not conduct heat, right? We will study about this in the chapter. I don't remember the chapter name. There's a chapter called Heat Transfer in Nature. I think it's the 8th chapter, if I'm not mistaken. 7th or 8th chapter. Now, let's next move to the conduction of electricity. Conduction of heat we studied. Let's now understand the conduction of electricity. Okay. So now, if you have ever seen an electrician who comes to your house to repair something, he will always be carrying a screwdriver. Okay, he will always be carrying a screwdriver and the tip will be made of a metal, but the screwdriver is generally made of a material which is not a good conductor of electricity. Why? You've already studied that in the electricity chapter, so that he does not get an electric shock if there is some kind of transmission of electricity, right? So he would be either wearing rubber gloves, he will also be wearing shoes, he may wear a helmet, and he will use a screwdriver, which the material of the handle of that screwdriver will be a non-conductor of electricity, right? So what we studied in the previous chapter. So you would have observed that objects made of aluminum, iron, and copper make the bulb glow, whereas sulfur, coal, and wood and stone eraser, they are all insulators of energy, electricity, or non-conductors, right? So materials which allow electricity to flow through easily, they're called good conductors of electricity. In contrast, materials that prevent the bulb from glowing by not allowing electricity to pass, they are known as poor conductors of electricity. So which is why the plastic covering on the screwdriver, the rubber gloves, they are all preventing the electrician or any one of us from preventing it from getting an electric shock, which is why all the rubber glove is a poor conductor of electricity. So they keep us safe. So now what all we have learned, that metals have shine, they are lustrous, they are malleable, they are ductile, and they are good conductors of heat and electricity. I hope all these things you have understood it completely. These are the important things. Now let's learn how metals behave in both air as well as in water. You know, when you put water on iron, how does it react, and how does it react even in air? So the effect of air and water on metals on a piece like this, which is made of iron. Now, what happens when it is in contact with dry air? What happens when it is in contact with water only? What happens when it is in contact with both air as well as water? These are three different conditions, and it will behave differently in the three conditions. So let's take an iron nail. Okay, a nail that you put on the wall. We put it inside a jar, and inside we have put some silica gel, so that it kind of absorbs the air. So silica gel, so it makes the air dry, which means that any moisture that will be there, any humidity which will be there, that will be absorbed by the silica gel. So if you have seen silica gel, small pouches, it will be there in your boxes, it will be there inside your cupboards, etc. It's basically to ensure that there is no humidity. Whereas if there is humidity in the air, and if it is there inside the shoe rack, even in the shoe rack, you will have silica gels being put, because if you have humidity, the shoes will smell. Also, they may get spoiled over a period of time. So it is basically to keep the air dry. That is the role of silica gel. That's also something which you need to know. So the first one, you put silica gel, that is in the presence of air. The second one, you put it completely in water. Then you put oil on top, and then you have the air on top. So the oil is going to prevent the air from coming in contact with the water. So that means it is completely in water. Otherwise, if you did not have this oil, then the air would have been in contact with the water. So here, the oil is going to prevent the surface of oil is going to prevent the air from dissolving in the water. That is the second condition. The third condition is the most significant one, and I want you to pay attention to this, where the iron nail is 3/4 in water or 2/3 in water, 1/3 it is outside in the air. Now, what will happen in the three conditions? That is something which you need to observe. What will happen is that in first bottle and the second bottle, glass bottle A and glass bottle B, the iron nails do not show any brown deposit. There won't be any brown deposit. What is that brown deposit? I will tell you. There will be no brown deposit. It will continue to be white or black in color. There will be no brown deposit on the iron nails in the first jar and the second jar. However, in the third jar, where 2/3 of the nail is inside water, 1/3 of the nail is outside in the air, there what happens is that it will show some brown deposits being made in glass bottle number C. The iron nail shows the presence of brown deposits. Okay, so this indicates that the presence of both water and air is essential for these deposits to develop. Now, what are these deposits? These deposits are rust. So the process of formation of rust, which is that brown color thing, on objects which are made of iron. Now, this is specific to iron. We are now talking about only one metal, which is iron, where if you have both water and air, it can rust over a period of time. Now you may say, what happens when it is being cooking? When it is being cooking, you are going to clean it every time so that there is no rust formation. Whereas if you keep it inside a cupboard for a long time, and there you also have some humidity, some water, some moisture, and it is also in contact with air over a period of time, and this could run into weeks and months, it could start developing some brown color deposits which are called rust. Okay, now other metals also exhibit discoloration when it is kept in the atmosphere. For example, if you have a copper object, okay, you will see some kind of a green coating on top of that copper object. Or if you have a silver, now this is something which you would have seen, silver. If you have a silver color lamp, okay, if you keep it out in the open, and there is also some moisture in the air, right? If it is raining outside, the air inside the house also will be a little humid. So you will see that the silver color lamp that you have will, you put silver color lamp in your puja room, etc. That will start developing a black color on it. For that, you kind of use ash, etc., to clean it. Then it becomes clean. But otherwise, there is a black color thing. So this is because of the gradual deterioration of deterioration means, it is going down in quality of the metal surface because of air, because of water or other substances, and this is called corrosion. So when it happens in iron, it is called rusting. When it happens in other metals, it is called corrosion. So that is the major difference. So what I've done here is I've told you in the form of two tables. So corrosion is the general term for the gradual destruction or deterioration of metals due to a chemical reaction with the environment. That is corrosion. Rusting is a specific type of corrosion. Rusting is a type of corrosion, but all corrosion is not rusting, because rusting takes place only in iron, not in silver or not in copper. Okay, so that is the big difference. So please remember this table, take a screenshot and keep. So rusting happens only in the case of iron, okay, or iron-based materials. Corrosion can happen to many materials, not just iron. Rusting, I repeat, is a form of corrosion, but all corrosion is not rusting. Rusting happens when iron reacts with oxygen and water to form iron oxide. So that brown color deposit that you see is actually iron oxide. It is called rust in common terms. Corrosion example is copper turns green, silver turns black, iron also rust. These are all corrosion. The reddish brown kind of powder that you formed on iron, that is called rust. So this is the difference between corrosion and rusting, which you should definitely remember. Now, if you see, if you have ever been to the Qutub Minar, you would see an iron pillar which is there. Earlier, there would not be any cage, but now there is a cage which prevents people from putting it. Earlier, when we had gone as kids, there is a thing that you can actually not go behind. You don't rotate your hands behind, and you cannot hold the entire pillar. It's so wide. So this is known as the iron pillar, which is there in the Qutub Minar complex. Okay, now the interesting story about this is that it does not rust. It has not rusted at all, despite it being there for so many years. So why hasn't it rusted? It is a fascinating example of Indian metallurgy is the study of metals. Okay, so because of the quality of Indian metallurgy at that point in time. So because the iron that has been used in that pillar is of such high purity, with very little sulfur and manganese, which usually make the iron rust more easily. So a thin layer of iron hydrogen phosphate formed naturally on its surface, and this acts as a protective barrier against oxygen in the air and moisture in the air, right? So this is the reason why the iron pillar has not rusted. Please take a screenshot of this, because this is how you need to write the answer as to why the iron pillar has not rusted despite being there for so many years. Now, the interesting thing, I was wondering, why is it there? Because this is not during the Qutub Shahi, the Delhi Sultanate period. And I did a bit of history. And incidentally, it's also part of your history textbook, but I will already tell you, right? How is the iron pillar near the Qutub Minar, right? The iron pillar actually is older than the Qutub Minar by around 800 years. If Qutub Minar was at some time, this one was 800 years old before the Qutub Minar, right? So the iron pillar was actually not initially there at near the Qutub Minar. It was located near Udaygiri in Madhya Pradesh, in modern day Madhya Pradesh. And the inscriptions there are of Chandragupta Maurya. And from there, this iron pillar was transported to the Qutub Shahi complex, Qutub Minar complex, and put there. So that is the story behind the iron pillar. So you see this thing that the if you want to prevent rusting of iron at your home, etc., you either paint it or you put a layer of oil, because of which the air will not get into contact, grease it, or you apply a protective layer of zinc metal on iron. And we will learn about this in the higher grade. So this is a iron pillar which was there, Chandragupta Maurya. So now it's over 1600 years ago, and it is 8 meters high and weighs more than 6,000 kilograms. And despite all these things, it has not rusted at all. So it is fascinating. Okay. Now let's read about the effect of air and water on other metals. We have read about iron so far and about silver and copper, etc. Let's read about on other metals. So here what you need to do is this has to be done only in a lab, and it cannot be done by you directly. You need to have the lab technician, lab assistant, or your teacher with you. So you carry a magnesium ribbon, okay, which is about 3 to 4 centimeters long. And then you clean it with some sandpaper so that, it is clean completely. Hold it with a pair of tongs so that your hand does not get burnt or get hot. And then let the magnesium ribbon burn, okay, on the flame, as it has been shown in the photograph. It is the burning magnesium ribbon. So when it burns with a dazzling white flame, it changes into white powder. The powder will fall down. You need to collect it with that watch glass, which you see. This is the watch glass. So the powder that is formed is magnesium oxide. Magnesium reacting with oxygen around to form magnesium oxide. Okay. Now you add a few drops of warm water to this white powder. And as you have seen in the second chapter on exploring substances, we will see whether it is acidic or basic or neutral in nature. Okay, so we use what? Red litmus or blue litmus paper. We see that it changes the color of red litmus paper to blue. Therefore, it shows that it is basic in nature, right? So that means that all oxide is formed when the metal reacts with oxygen. Oxygen, oxide. Magnesium reacts with oxygen to form magnesium oxide. So oxides of metals are basic in nature. They are not acidic in nature. Okay, so that is something which is there. We will read about this more in detail in the next chapter. I will show you a figure at that point in time. Now, sodium is a metal, okay, and it is also stored in kerosene, because otherwise it will react with metal and it will catch fire. Okay, so storing sodium in kerosene prevents its exposure to oxygen and moisture, and that's what happens. So metals, oxides, I've already told you, it is basic in nature. Now there are some substances that behave differently from metals in air and water. Now these are not metals, but they will behave differently in both air and water. So what we do is to do this activity where you carry some kind of a spoon with a long handle, okay, where the metallic wire is used as a handle. You heat it. It has sulfur inside that, okay. So the sulfur starts burning, okay, and then you put it inside a jar like this, okay. When it starts burning, you put it inside a jar like this, okay, and then you take out the sulfur and shake it so that the gas dissolves. So using an acid-base indicator, we will see what is the thing. So when you burn sulfur in air, that is in oxygen, sulfur dioxide is formed, sulfur plus oxygen, sulfur dioxide. And on dissolving sulfur dioxide in water, sulfuric acid is formed. So that is how it is acidic in nature and not basic. So these are some materials which react differently and they are acidic in nature, whereas the oxides of metals are always basic in nature. This is something which you just need to remember. Okay. So now the thing is that if you have sulfur and phosphorus, they behave differently with air and water than metals. We have already seen that. Phosphorus is stored in water because if you expose it to air, just like kerosene is mixed with, sodium is mixed in kerosene. Similarly, phosphorus is mixed in water because otherwise it will catch fire if it is exposed to atmospheric air. Now, these are materials, substances which are neither malleable, they're neither ductile. You cannot make wires out of this. They don't create a sound, so they are not sonorous. So you see, they don't have any of the metals qualities, neither malleable nor ductile nor sonorous. So that means they are non-metals. They are also poor conductors of heat and electricity. So none of the qualities that we saw with metals, these non-metals have, and their oxides are also acidic in nature. So you see, there are these 6 things. I repeat, they are not malleable, they are not ductile, they are not sonorous, they are not a good conductor of heat, they are not a good conductor of electricity, and their oxides are acidic in nature. These are the substances, examples being sulfur and phosphorus. Please remember that. Now there are some non-metals. Okay, there are some non-metals like oxygen. Now oxygen, etc., you will find it in the periodic table, etc. Hydrogen, nitrogen, carbon. Now these must not be confused with materials like plastic, etc., because these materials are not classified as metals and non-metals. This plastic, rubber, wood, etc., because they are not elements. Whereas oxygen, hydrogen, nitrogen, etc., they are elements which you will find in the periodic table, about which we will study in class 9. Periodic table, class 9 and 10. Now, metals and non-metals are subcategories of elements. Elements, and then there are metals. There are some are non-metals. There are some metals. There are some non-metals. An element is basically, what is the definition of an element? An element is something which cannot be broken down into simpler substances. So if you have a nitrogen, you cannot further break it down into something simpler than nitrogen. You cannot. So that is what is called an element. So presently what we know about is 118 elements. Okay. And it is with the, like, nitrogen reacts with hydrogen, nitrogen reacts with oxygen. So they form further things, but these are the basic building blocks is what is called. Okay, hydrogen reacts with oxygen to form H2O, which is nothing but water, right? So that is what it is called. Hydrogen reacts with sulfur to form hydrogen sulfide, which is H2S. So all these chemical formulas, etc., we will study about them in class 9 and class 10. Abhi bahut kuch baki hai. Okay, now, are non-metals essential in everyday life? Okay, are non-metals essential in everyday life? Now, obviously they are. It's not as though only metals are important. It's not as though only iron is important. There are other non-metals also which are very useful in everyday life, right? Even though they don't have the metallic quality, right? Carbon, for example, is essential because it's the building block of all life forms. Carbon we have seen being used to build the suspension bridges also, because it lends weight, right? It is also a key component of proteins, carbohydrates, fats, etc. Nitrogen, very important because it is used by farmers in fertilizers, okay, which will help in better agriculture, better growth of crops. Chlorine, you see it being mixed in swimming pools so that the water is kept more pure, more clean, right? It is used for water purification. Iodine, it is used in your salt, right? It is used as a antiseptic. If you have a wound, iodine is used there. So you need to know the use of all these things, or you can be asked a question, which non-metal is applied on wounds as an antiseptic? You cannot write chlorine, galat ho jayega, anda milega. So you need to write iodine. Which non-metal is mixed in water to purify it? It is chlorine. If you have ever gone to a swimming pool to learn swimming, you will find that chlorine is mixed in it. Sometimes it gives a smell also, but chlorine is mixed in it, and sometimes it can also give you a skin itch. That's a different matter, but it is used to purify the water, because if so many people come and swim in the swimming pool, the water will get a little dirty and infected as a result. So they mix chlorine in order to keep the water pure. So then comes the thing again about which you will learn in further classes about metals and their alloys, which means when metals, two or more metals are mixed, or a metal is mixed with a non-metal, what happens? They kind of create an alloy. So a metal plus metal, metal plus metal, or metal plus non-metal, it is forms what is called an alloy. Now, what are the examples of alloys? And alloys are very useful. There is an alloy called zirconium. Okay, zirconium, which is used in atomic energy. There is an alloy called titanium, which is used in aerospace. Many of the bodies of the rockets, the aeroplanes, etc., titanium is used. So these are all used in order to give strength, and they have these different uses. Again, about alloys we will study in class 10. So this brings us to the end of this particular chapter. Share and subscribe the video, and I do hope it is absolutely clear. What I want you to do now is to read the chapter again from your textbook so that you get more clarity, you understand all the activities that are mentioned out there, you go through it so that it becomes like a second revision. In any case, I keep repeating my point so that it kind of gets registered much more. We will also do the questions and answers separately so that if there is any doubt there, that will also get resolved. So share the video, subscribe to the channel, and thank you for your time. Thank you for your patience. Tata, bye bye. Namaskar.